Last lesson, we introduced what simultaneous equations were and how to solve them. This lesson, we take that a step further. So can you write the title and learning objective underneath your last lesson of work? Make sure you've underlined in purple pen, written the date, you know, the usual. Pause the video so you've got time to do that and press play when you're ready to continue. So in our last lesson, I introduced a couple of questions that looked like this. Had this sort of structure. In fact, I think this was the first question that we looked at last lesson even. Now in this situation, we had two equations. Why am I going to do this in purple pen, not black? Be asking yourself. Two equations, two unknowns. And I said, if you have two equations, two unknowns, you're going to solve them simultaneously. You're going to do simultaneous equations. And you go through that whole process. You decide which of x or y you want to eliminate. You decide if you're going to add or subtract, and that goes in this box. You solve to find one of them. Then you subs in. And then you checks in the other. This was your strategy. If you weren't happy with that, if you're not happy with that now, you need to re-watch that video. If I were better on YouTube, I would have like a little pop-up thing saying, click here for lesson 1 or something like that. But I'm just telling you, you need to go and find simultaneous equations 1 video and do it again if you don't understand it. Because today's lesson is only going to be accessible to you. You're only going to understand it if you are able to fully understand the first lesson. So I'm going to leave just these two equations on the screen. And I'm going to compare these to these two equations. Both equations have two unknowns. Sorry, both sets of equations have two unknowns. We've got this set here in red, and we've got this set over here on the right in black. Both these sets of equations have two unknowns, x and y. Both sets have got two actual equations. But can you see something that is crucially different between them? There is a key difference that you need to spot. Pause the video if you need a bit more time to try and spot it before I say. Well, hopefully you can see in the first pair of equations, in the red side, we've got this helpful plus y in both of them. So it's very easy for us to be able to say, okay, we're going to target the y's, we're going to eliminate the y's. What do I need to put in that box to eliminate these two positive y's? Well, I need to subtract, because positive y take away positive y will give us nothing. But on the right hand side, the number in front of x is 2 and 1, so they're not the same. But the number in front of y is 3 and 5, so they're not the same. And so today's lesson is looking at how to solve simultaneous equations when we don't have the same number of x's or y's in either equation to start off with. So we know how to do these. Let's get rid of that and let's focus on these two equations here. Now I want you to read the learning objective because it basically tells you how we're going to do this. So what we're going to do, still labeling them A and B, but we are going to multiply one or both of the equations to get the same amount of x or y. Once we've got the same amount of x or y, we can solve them simultaneously like we know how to. So which do you think we're going to try and target, which do you think we're going to multiply, and what are we going to try and get the same of? Well, if we try and target the y's, how could I get the same number of y's? I'd have to multiply a by a number that got me 15, and I'd have to multiply b by a number that got me 15y. Why have I chosen 15? It's because 15 is the lowest common multiple of 3 and 5. So to get the y's the same, I'd have to multiply it by 5. To get the b's the same, the y's the same for b, I'd have to multiply by 3. That would give me 5a equal to 2 times 5 is 2x times 5 is 10x, 3y times 5 is 15y, 20 times 5 is 100, and then 3b, 3 times x is 3x, 3 times 5 is 15y. Great, now they're the same. Now I can eliminate them. 3 times 31 is 93. So that would work, but it's more complicated than it needs to be, guys. In fact, I would not choose to eliminate the y's first of all at all. Let's try this out again over here. Why would I not choose to eliminate the y's first? Because to eliminate the x's would be much easier. All I would have to do is multiply equation b by 2 in order to get 2 x's. Then the x's would be the same and I could go about eliminating them. The equation A, that could stay exactly as it was. A could stay as 2x plus 3y equals 20. B, I timed by 2. You see how I write this 2 here? And that would give me 2x plus 5y times 2 is 10y. 31 times 2 is 62. So from here, that is much easier for me to eliminate the x's because all I had to do was times these things by 2. Sometimes we're going to have to multiply both the equations by numbers, like over here, in order to solve them simultaneously. But when we can, we should only try to minimize the number that we are multiplying. Let's go back to my purple strategy. So I'm going to eliminate the 2's, 2x's. How do I eliminate positive 2x and positive 2x? Well, I take them away from each other. I then have positive 3y take away positive 10y. Positive 3y take away positive 10y. And that's the same as 3y minus 10y, which is negative 7y. And 20 minus 62 is negative 42. Divide both sides by negative 7, and we get y equal to 6. Next step is like it always is. What do you think I'm going to do? I'm going to subs in. Because I found my y solution, now I need to find my x solution. So subs in A, 2x plus 3y equals 20, but now I'm going to exchange or substitute, what I'm talking about exchange, substitute y for 6. I get 2x plus 3 times 6 equals 20, which is 2x plus 18 equals 20, which is 2x equals to 12, and finally x equals 6. So that is my second solution. But if I subbed in A, I checks in B. X plus 5y equals 31. Notice I'm not checking in this second B here, the one that I've created by timesing everything by 2. I'm not doing that. I'm checking in the original B, this one here. Always check or substitute into the original equation. So instead of x, I'm going to write my solution for x, which was here. Instead of y, I'm going to write my solution for y, which was over there. So therefore I know that those two are correct. Let's look at another example. Here's another question I want you to try, this time on your own first of all, and then when you've had a go, press play so that you can hear how I do it. So pause the video, good luck. So again, we go A, B, but we can see we don't have the same number of x's and we don't have the same number of y's. So we've got to decide which of the x's and y's we want to make the same. If I try and make the y's the same, I'll have to multiply both of these numbers. I'll have to multiply the three, I'll have to multiply all of A to get 15y, and I'll have to multiply all of B to get 15y. Whereas if I target the x's, I'll only have to multiply B in order to make it 4x. So I'm going to multiply B by 4. A is going to stay as it was. I'm actually going to write B on top because I think it will make it a little bit easier for when I come to doing the adding or subtracting. So to times B by 4, I have to do 4 times x, 4 times 5y, 4 times 19. I'm then going to write A underneath it. It just is as it was originally, 4x plus 3y equals 25. Now it's all about deciding whether I'm going to add or subtract in order to eliminate these two 4x's. Well, if they're both positive, 4x and 4x, how do I eliminate them? I'm going to subtract. And now you can probably see why I wrote 4b, this equation, on top of A, is because it takes away more nicely when we do 4b on top. So that's a top tip. Sometimes you may want to write equation B above A to make the calculation easier. Because now all I have to do is 20y take away positive 3y, which is 17y, and 76 take away 25, which is 51. Divide both sides by 17 and I get y equal to 3. And that's my first solution. Now I'm going to subs in to the original B. You never want to substitute or check in the new equations like this one, because you may have made a mistake when you timed this equation A by 4. So always substitute into the original equations. If you want to write a top tip again, you write it next to this, subs in B, top tip, always subs into original A or B. Always subs into and always checks into. Subs in A, checks, sorry, subs in B, checks in A. And make sure we're substituting to the original A and B, not the ones that we've multiplied. So let's write out B. Instead of y, I'm writing my solution for y, which was 3. And I get x equals 4. So now I've got two solutions for x and y. I now need to check in the original equation. I'm checking in A this time because I substituted into B over here. So instead of x, I'm writing 4. Instead of y, I'm writing 3. And if I've done this all correctly, then this side should equal this side. 25 does equal 25, so I know that these are correct. If you've got that right, very well done. Make sure you've written my top tips down in purple pen. If you got it wrong and you're not sure about where you went wrong, just rewind the video and have another go, or rewatch my explanation. We're going to do one more example before I give you some independent practice. So, pause the video and have a go at this. So for this one, we're in a situation where the x's and y's, neither of them are the same. And also, it doesn't look like we're going to be able to multiply just one of a or b to get the same number of x's and y's in both. We're going to have to multiply both equations. So I can either target the x's, which would mean I had to get the lowest common multiple of 6 and 5, which was 30. So that would involve timesing a by 5 and timesing b by 6. Or I could target the y's, which would involve timesing a by getting 10y for both of them, so timesing a by 2 and timesing b by 5. 2 and 5 are smaller numbers than 5 and 6, so I'm going to choose to target the y's because it's going to make my life a bit easier because the numbers that I'm using will be smaller. So let me target the y's. Aim is to get the same number of y's for both a and b. So instead of a, I need to multiply it by 2. And that will give me 12x, because 6x times 2 is 12x. It will give me plus 10y, which is what I'm aiming for. And 20 times 2 is 40. For equation b, I need to get 10y, so I need to times that by 5. So 5 lots of b. 5x times 5 is 25x. That is 10y, that was what we were aiming for. And 5 times 21, well 5 times 20 is 100, plus 5 times 1 is 5, so it's 105. So these are my equations I'm going to be using. Now this is one of those situations where it would actually be easy if I'd written b on top of a. So I'm going to take the time to write it out again nicely. And now, when I come to add or subtract, it's going to be cleaner because the bigger equation with the bigger numbers is on the top. That was my top tip from before. So to get rid of these 10y's, I've got positive 10y and positive 10y. I'm going to be subtracting. 25x take away 12x is 13x. These guys are cancelled, and I'm left with 65 over here. Divide both sides by 13. 13, 26, 39, 52, 65, 13. You know what, guys? I'm not that confident of this in my head, so I'm just going to take the time to write them out over here. What am I doing? So that's 2 lots of 13, 3 lots of 13, 4 lots of 13, 5 lots of 13. And when I divide them both by 13, I get x equals 5. There's a lot of steps to this. Well, no, there's the same number of steps, they're just a bit more complicated each one. So, I've got one solution. As always, the next step is to subs in one of them. I'm going to subs in B into the original B over here. But if I subs in B, I checks in A. Make sure you're checking the original A over here. So 5x plus 2y equals 21. 5 bracket 5 plus 2y equals 21. 25 plus 2y equals 21. 2y equals negative 4 if I take away 25 from both sides, which means y equals negative 2. And that's my other solution. Check in A. So instead of 6x plus 5y equals 20, I substitute my solutions for x and y. (30 minus 10 equals 20). 20 does equal 20, so I know these are correct. Pause the video, make any notes that you need to, and press play when you're ready to keep going. Right, we're going to do some independent practice. So I want you to have a go at these questions here. Question 1, question 2, question 3. Pause the video so that you've got time to do them, and when you're ready to see the solutions, press play. To save time, I wrote out the solutions earlier. Here they are. You can see the strategy is always in purple. And for the third question, I did both different ways, if you made the x's the same or made the y's the same, because I thought it was likely that some of you did one way and others of you would have done the other way. So pause the video and make sure you've marked all your work. And don't forget, when you've finished this video, I want you to take a picture of all of your working from this video, and you're going to send it to me on Friday. See you later.